So giving everyone about 10 minutes to do this because it's still pretty fresh. Domain, intercepts should be a breeze. Asymptote starts getting a little funky. So for those of you joining us through video, what I asked everyone to try was this example, which is example 7 from example 4, sorry. Example 4 from 3.6. Couple of things that you can do right away. You might have developed the eyes for this, so you might see that this was factorable. And in fact, you need to do this at some point. You'll see why. Second, you will notice that the degree on top is larger than the degree on bottom. So the numerator is larger than the denominator. Therefore, it has an oblique asymptote. It is not horizontal. You know these things right away. Let's start. Domain. X could be any real number, but X cannot be a -5, and that translates directly to a vertical asymptote. Intercepts. Let's do the easy one. What is the y value when x equals 0? Well, 0, 0, -7 over 0 plus 5, it's a 5. So my y-intercept is 0, comma, for the sake of graphing, we'll do -1.2. But I prefer leaving it as a fraction. For the x-intercept, in other words, when is f of x equal to 0? Well, that means the numerator equals 0, which means, go ahead. -7 divided by, yeah, which is, 1 over 4. Oh my gosh, 1 over 4, 1.4. No. Sorry, 1.4, -1.4, not -1.2. That would have been very bad. So again, let's go back to my, my x-intercept. When is the y value equal to 0? When the numerator equals 0. When will the numerator equal 0? If x equals 7 or x equals -1. These are my x-intercepts. Question for the intercepts? No? Go ahead, Zach. What's the question? Let me do this then. Just because some people might be, yeah. X is -5. That's my vertical asymptote. Again, go straight back to the restrictions. What makes a denominator a 0? For horizontal asymptote, there is none. Oblique, you're going to have to divide to see the end behavior. That's the hard part. Again, this is the new part. So let me do the division here. 1, -6, -7, -5, 1, drop it down, multiply, add, multiply, add. So f of x, if I continue graphing this, it will start to behave like mx plus b, not a quadratic, not a cubic, not anything crazy, but mx plus b. And I do have a remainder, but when we start talking about end behaviors, that becomes negligible. So negative and positive. Ooh. Is that a question? We don't care. Yes. So as x approaches a positive, f of x is going to approach this linear plus something, right? So you're adding a certain value to this. So it's going to essentially be x minus 11, but from the positive side of it. As I approach a negative infinity, what was in the back? Adam? Just write down. Yusuf? Just quietly. Okay. As it approaches negative infinity, it will still behave like this line, but 48 divided by a negative infinity is going to be subtracting a very, very small number. So if I were to argue, as I approach this line, I'm actually approaching it from underneath, from a smaller value, getting closer and closer to x minus 11. Finally, let's do the chart. I am putting every, I guess, term or binomial here that would change the sign. And I am putting all vertical asymptotes and x-intercepts in chronological order. That would be vertical asymptote. That's a 0. That's a 0. Yes, sir. Yes, you can. No. But I don't want to keep a number in my head and then do another subtraction and then another subtraction. I'd rather do this and multiply a plus or minus. It's easier for me. Okay, filling in the chart. -6, that's a negative, that's a negative, that would be a negative, negative. A number between, how about -2? That's going to be a negative, that's a negative, that's a positive, that's going to be a positive. Number between these two is a 0, negative, 0 plus 1, 0 plus 5, negative. And anything larger than a 7, that would be a positive, positive, positive. In my head, I just plugged in like a 10. There's my graph. Moment of truth, right? Let's hope all of our calculations agree with each other. Vertical asymptote at -5. That's a -5. A 0 at -1, a 0 at 7, an x-intercept at, sorry, these are my x-intercept. My y-intercept is, so -1.4, right? So somewhere around here. 1.4. I made a mistake. -7/5 is 1.4. And lastly, my end behavior has a positive slope of 1, beginning at a y-intercept of -11. So somewhere down here, but for the sake of, I need more space. Darn it. So -11 would be somewhere around here, I guess. And then it has a slope of 1. So if I keep going up by 1, 1, 1, 1, 1, 1, 1, I'm probably going to cross the x-axis at 11. See if I could do this. There. And that is x minus 11. Okay, the last bit is taking a look at the end behaviors and the behavior around the asymptotes. I hope it agrees with all these dots. If I am to the left of my -5, it is going to be a negative value. To the right of my -5, it's going to be a positive value. To the, oh, these are x-intercept. Okay. When I come from the negative infinity, it's going to be below my asymptote. It's going to be right here. And if I go to positive infinity, it's going to be above my asymptote. It's going to be somewhere here. Let's connect the dots. There it is. Yes. Oh, it's the equation was x minus 11. So compare that to mx plus b. You know that m is going to be a 1. Does that make sense? No? I'll say it one more time then. Well, how about this? If you know that it's x like plus 5, right? Or x squared minus 5x plus 2, what would you say is the leading coefficient? 1. It's the same thing here. When I divided, the leading coefficient of my quotient was a 1. So I know that's a 1, and therefore the slope is a 1. Mm-hmm. Crazy stuff, I know. It's satisfying, isn't it? Right? It's satisfying largely, in my opinion, because it's something that you found to be difficult at first, but you know it's doable. It takes a lot of work, yeah. But that work, as you get better and better at it, will seem smaller and smaller. It'll be more and more manageable. So take the 20 minutes per question, take the 30 minutes per question, and you will see soon enough that that number gets smaller and smaller. Don't give up on it. So the remaining class, we have about 30 minutes. I'd like you to try. So basically every type of question is now open to you, right? I could give you a 1 over something like on our mini quiz, right? I could give you an x over something. I could give you a degree that's larger than something, right? So every possibility you should be able to do as long as you're patient with it and that you don't give up and you persevere. So every question that I've given you in 3.6. So in the first piece of paper, there's questions with x over x squared or x squared over x squared. On the second piece of paper, it's all oblique asymptote examples. And just in case this may not be enough, I am going to go ahead and use this 30 minutes to write up answer keys for all of these questions. You do not have to do them all. But I understand that our textbook has very little examples for oblique. And if I'm going to test you on it, well, you should have some example questions. I'm going to commit myself to making an answer key to every single graph here, which means I need lots and lots of paper to draw. Please take this. And if you do, in fact, run out of questions to do from here, why not start with like A, C, E, and you know, do it until you feel confident. And if you feel confident, don't do the rest. The goal is to be comfortable with this material. Yes, Jess.
Are we only going to see that are 1 graders in the line?
I think it'll be tough to actually sketch the parabola at this point in time. Let me double check what we decided for our evaluations. But for the moment, I will say you only have to worry about a difference of 1 degree. For now. Yes. Yes, I'll do that. Yes. Any other questions? Yes. I think so. So should be at least. I can't guarantee, you know, thinking questions where I ask you to do a question in reverse, like I give you a curve or I give you an equation and say, hey, what would the division be or whatnot? I can get pretty creative. But if you can do all of these questions, K questions are for sure not going to be an issue for you, 100%. So let's practice that. Okay, I'm going to stop the video and I'm going to start working on this answer key. The rest of time, please use as you see fit.